what we call orbital replacement units, ORUs, or basically spare parts for the International Space Station. So a lot of times we will have our commercial partners that build those parts coming through here, and they will process and we will get it ready for flight to fly up on a commercial resupply mission, either a Dragon or a Northrop Grumman Cygnus module. So we have 8 footprints in here. You can see the numbers at the top. We have 8 of them. Right now we have footprint number 2 that NASA is using to launch what's called a battery charge discharge unit, a BCDU. So that's one of the interesting ones we're going to stop at. We also have Sierra Space using these 2 footprints right here. They have a lot of neat stuff. We have an Iron Bird, which they use as a mass simulator for their Dream Chaser vehicle, and their new habitat. This is their mock-up of a habitat, which you guys are going to go see. But starting with just some fun facts about the International Space Station, if you do stand here at this sticker, and you look all the way to the far wall, that is trust the size of the International Space Station. For their Dream Chaser vehicle that's going to be resupplying the International Space Station next in their CRS-2 missions. So this piece right here is a massive CG simulator. It was used to test out a lot of the ground support equipment that Sierra Space is going to use to process their Dream Chaser. So there's a really nice time lapse of the operations that they did on Twitter right now from NASA Kennedy Space Center.
You can see their Dream Chaser up there. It's the winged vehicle. They developed for crew. That cargo module at the back end is kind of a pear-shaped piece. They developed that so they could take more cargo to ISS. And so that's an uncrewed version of their Dream Chaser vehicle, and I think they call it the cargo version. But so they'll process that through here. There's actually a tape outline of the winged vehicle on the floor there. It'll get loaded with cargo here. It'll launch on the new ULA Vulcan rocket in a fairing, and then it'll land at the SLF, and we'll get cargo off really fast because that's a quick return to orbit, a very gentle landing. Cargo right back into those science labs. So science coming back from ISS, right back for eager science teams back in those labs we just visited. So then Dream Chaser will come back in here for refurbishment by Sierra. They work very independently, but we host them here in the SSPF. And to me, this is really exciting because that's a commercial contract where they work very independently from us, but we get to repurpose this ISS building that was built for module processing, and now it's a repurpose for this commercial resupply. So really good. And then this giant inflatable hab, Sierra developed that as part of a NASA Next Step program, and it was a concept for hab modules for Gateway, the lunar outpost. So I think 5 different companies developed concepts for that. Lockheed's prototype is at the other end of the building. We'll go visit it. Sierra's is here. It's this giant inflatable space, and we're going to go meet with them next, and they'll walk us through it.
What we have in front of you here is about 1/3 of the volume of the ISS. It's about 300 cubic meters. This compresses down and fits in a single 5-meter fairing, so in one launch, you can get 1/3 of the volume of the ISS. And that's really one of the really neat features of our life habitat.
This is going to space. Nobody in there. All right, so obviously there's some positive pressure. What you going through there?
We've got a lot of
So John will tell us a lot more about this, but on orbit this would have 3 levels. We'll get to visit 2 of the levels. I've been in probably every module in ISS, and it's really dramatic to come in here and see how big this diameter is, how much space is in one module that would launch on one mission and then inflate.
All right, so as you walk in here, you see the main core structure. So this is what everything, the soft goods and everything we build out, folds down around the core structure, and we pack up. And it's vertical, integrated launch vehicle launch. From from there, compressed gas is used to inflate the soft goods structure. So right now on the ground, what we do is we have just a big fan motor effectively on the outside that pushes air in to inflate this mock-up. General layout that we have for this, you see right now, there's 3 decks. So there's one above us, this main deck in the middle, and there's a deck below us. For space, what you'll see is a cutout in the middle that's a tunnel, so you can transfer between the decks and go up and down. Of course, that doesn't work very well for the ground environment here. We're testing things out. I'll lift this up so you can see before we go upstairs, just kind of an idea of how much room this actually is. So if you look down there, it's a huge amount of room.
Yeah, sure.
Yeah. That's one of the big advantages of this approach. So we don't have anything on the bottom side, because again, it doesn't make sense to do that in the ground environment. And you see a lot of the space is taken up here. We've got 2 big ladders on either side to just, again, work in the ground environment. Those go away when you go to space. Generally, the layout in this horizontal stack configuration, you see there's these natural quadrants. So when we built this, we did some initial kind of mock-ups of what payload racks, what glove boxes. At one point in time, we had some things in here to look like a medical bay. So we were doing some early evaluations with the NASA team out of JSC and getting astronaut inputs of what works within the layouts, what doesn't work, and such. You'll see down the middle we have some racks. These are mock-ups of size to hold avionics, EPLIS, some of the subsystems for the station. Behind you over here, you can see a mock-up of our Astrogarden, which is an evolution of some of the plant habitats that we make right now for growing plants in space. Questions, sir?
So this is the core.
Yep.
What structure is with the inflatable as it, when you first take it up?
Yeah, so the decks that you'll see here again are made to hold the loads for everything. So there's a lot more space that's just taken up to hold the structural loads for everything we do on the ground. The floors that will come are actually deployable, and we're looking at a couple of different ways to do that. Actually, we might be able to do that with inflatable decks as well, to take a little bit more of the mass out. But that's all effectively packed in the core and deployed on the initial.
And then you'd outfit it with the other lab equipment. And
That's right, yeah.
racks.
So through logistics missions, 1 to 2 missions, we can get a pretty good percentage of the outfitting deployed and ready for astronauts for the first crew missions. We can take a walk upstairs. So we're actually in the process of pulling a lot of things out of here because we're going to move the habitat to another building. Coming over the next couple of months and start to redo some mock-up tests in terms of outfitting. Behind us, we had some just general areas that were slated sidewise to be crew quarters, laboratories. We at one point had kitchen-type facilities in here, different workstations, but we kind of set it up so we can move those things in and out and kind of test it out and get evaluations, work with various folks and see how those work.
For the packaging, is it all manual as far as compressing it and getting it into launch configuration?
Yeah,
or do
that's
you
right.
have equipment that assists?
There's always equipment that assists in that, but that is a manual process. But of course, since we designed it for Gateway originally, we designed it for deployment side with robotics in mind, doing it on hand. So we want to maximize the ability to do it without astronauts present. So when astronauts do show up, their workloads are minimized and they're ready to go as fast as possible. So there's actually a tie-in, as Randy's talked about, is we see a huge commercial market, and in fact, NASA is an important anchor tenant, one of our most important customers. But we've got a lot of other customers that we're developing and developing towards that market. So there's a tie-in on the industrial engineering side, because one of the things that we do in model and analysis space is discrete time models. So in a lot of the industrial engineers, they work in software packages like called Arena and things like this, and they develop these models and do optimization of them. We've developed a model that models our operations in an industrial engineering type sense using a discrete time engine model that we integrate the missions and the customers and the manifesting. We integrate a space segment that looks at all the timelines within the space segment. We have the ground segment, the timelines associated with the ground segment, because there's a huge portion of this optimization and process optimization that we do to predict the future state of our station. And so we have a good handle on it from the ground transportation, or the transportation side, because Dream Chaser and the work that we're doing there with NASA for commercial resupply contracts. And then we estimate what our market demand is in terms of NASA side and commercial side in terms of payloads and people, and how do we manifest those? How many vehicles do we need? How do we need to size our ground facilities so that we can do the refurbishment of our vehicles? How long is a vehicle in space versus how long it's in ground? And what's interesting is when you look at it from that perspective, as spacecraft developers, we focus on space a lot. Turns out your big drivers are all on the ground in terms of timelines.
That's interesting.
Yeah, that is really your driver within the system, because once you're in space, you understand your customers, how long they want to be there, but the turns on the ground, the sizing of the systems on the ground become much more important. So that's when you talk about factories of 500,000 square feet to manufacture spacecraft, to do the refurbishment of the transportation vehicles. That really services, the space segment where you're talking about 1,000 cubic meters of volume. So your ground timelines are a big important piece of that. It's something that's sometimes subtly missed, and that's something that certainly the industrial engineering world is big into.